Section 11.6, Special Products of Binomials. In this video, we're going to learn to multiply polynomials using what we call the FOIL method. We're going to multiply binomials by finding the products that are differences of squares, and then we're also going to find products that are perfect square trinomials. In our example 1, we're going to be using something called the FOIL method. Now, the FOIL method is just a special way to multiply a pair of binomials. FOIL stands for first, outer, inner, and last. And what that does is it just gives you an idea of an order that you can follow to make sure that you have multiplied all of the various terms together. But you can also do this the same way we already did by just using distributive property twice. So here's the way that we do FOIL. So first means you're going to multiply the first term in each binomial, which would be x times 2x. Well, that's 2x squared. The outers are the two outside terms. So that would be x and 8, so plus 8x. The inner are the two inside terms, so that would be 3 and 2x, so that would be plus 6x. And the last would be the two last terms in each binomial, which would be the 3 and the 8, which is 24. And if you notice, that really is the distributive property that we used in the previous video. So now, combining like terms, we get 2x squared. 8x plus 6x would be plus 14x, and then plus 24. On our next example, if we do FOIL, first would give me 6x squared. Outer would give me minus 10x. Inner would give me minus 9x. And last would give me plus 15. Now, combining like terms, we get 6x squared minus 19x plus 15. One more set of FOIL problems. First, x squared. Outer, minus 7x. Inner, plus 7x. And last, minus 49. Now again, when I combine like terms, we're going to have x squared, but notice that our outer and our inner terms will cancel each other out, and we'll get minus 49. And that's a special case that we're going to talk about next. So let's talk about what we mean by the difference of two squares. Well, the difference of two squares is actually the answer to a multiplication problem that looks like the form x plus a times x minus a. So if you have the two terms exactly the same, but the sign between them are opposites, then what happens is when you multiply those together, you're just going to get the first term in the binomial squared minus the second term in the binomial squared. And again, just to show you quickly where that comes from, if I multiply first, we get x squared. Outer would be minus ax. Inner would be plus ax, and last would be minus a squared. But then the outer and the inner will cancel, and you get x squared minus a squared. So if we go back to our last problem, we had x plus 7 times x minus 7. Since those are both the exact same terms, but the signs between them are different, our x from our formula would be the variable x, and our a would be 7. So we'd have x plus a, x minus a. And so we know that the product of that would be x squared minus a squared, which would be 7 squared, which is x squared minus 49. So again, if you recognize the difference of squares property, it saves you from having to spend a lot of time foiling things out. So let's look at these three problems and notice that these will give us a problem whose answer is a difference of squares. So we have x plus 4, x minus 4. Our answer would be x squared minus a squared, which would be 4 squared is 16. In the second problem, notice that we don't have an x, we have a 3y plus 7 and a 3y minus 7. So we're going to treat the 3y as the x. So if our answer is supposed to be x squared minus a squared, then that would be 3y squared minus 7 squared. But that would be 9y squared minus 49. So really, if you'll notice, what you're doing is you're just multiplying the first and the last to get your answer. So now let's use that shortcut. If I have x cubed minus 6 times x cubed plus 6, if I multiply first, I get x to the 6th. If I multiply last, I get minus 36. Now again, that only works because we are of the form x minus a times x plus a. Our next special case is called the square of a binomial. If you're going to take a binomial and square it, remember that what you're doing is you're just multiplying it by itself. So if you forget this shortcut formula that they've given you for how to square a binomial, you can always just write it out twice and then multiply it out. So if we do FOIL for this, we would have x squared first. Outer would be plus ax. Inner would be plus ax. Now I want you to realize why I write this outer as ax. Normally if we have multiple variables, you want to put them in alphabetical order. So ax and xa are the same, but it's easier to recognize that these are like terms when you write them in the same order. So we've done first, outer, inner, and then last, plus a squared. So that's going to be x squared plus ax is 2ax plus a squared, which is the formula that they have there for how to square a binomial when there's a plus. Notice that it's exactly the same formula when you have a subtraction in the binomial, except for this middle sign is a negative. So whatever sign you have in between in the binomial is the sign of the second term in your trinomial. It is important that you realize that when you square a binomial, you always get a trinomial. So now let's find these products. We'll do this one by using our formula. So what's going to happen is here is my x and my a. So my formula says we're going to do x squared plus 2ax plus a squared. But that's going to be 2x squared plus 2 times a times x, and then plus a squared. But that's 4x squared. 2 times 3 is 6, times 2 more is 12x plus 9. Now honestly, I think that's more difficult than just to go ahead and FOIL these out. So you might want to just think of doing 5x minus 1 squared as 5x minus 1 times 5x minus 1. So first would be 25x squared. Outer minus 5x. Inner minus 5x. Last plus 1. Combining like terms, we get 25x squared minus 10x plus 1. So the nice thing about these is that you do have options as to how you want to do them. 9 minus x squared, we'll write it as 9 minus x times 9 minus x. If I FOIL, I get 81 first, outer minus 9x, inner minus 9x, last plus x squared. So that's going to be 81 minus 18x plus x squared, or if we put that in decreasing order, because that's the way we normally would write these, I'd have x squared minus 18x plus 81. One more problem, let's take y cubed plus 1 and square it. So we'll multiply y cubed plus 1 times y cubed plus 1. If we FOIL it, y cubed times y cubed is y to the 6th. Outer plus y cubed. Inner plus y cubed. Last plus 1. So that's y to the 6th plus 2y cubed plus 1. We'll go ahead and do that one also by our formula. So if we think of this as x plus a squared, we know that to be x squared So it'd be y cubed squared plus 2a, which was 1, x, which is y cubed, plus a squared, 1 squared. So that's y to the 6th plus 2 times 1 times y cubed would be 2y cubed plus 1, which was the answer we got when we FOILed it out. One thing that is a very common error when squaring binomials is that many times what students like to do when they square two terms, like in the case of x plus a squared, they want to just square the first term and just square the last term. If you do that, you're going to have the wrong answer because, as I stated earlier, anytime you square a binomial, your answer is a trinomial, and the way that this is set up, I only get another binomial. So if you are not sure whether or not you can just square the terms, then you can write it out and go ahead and just do it by FOIL, and then you'll see that your outers and inners will give you a third term so that you have a trinomial. Or again, you can just remember that every time you square a binomial, your answer has to be a trinomial.